Hello students, here we will study the fluid pressure. Okay, so here the pressure in fluids, just now we have discussed a little bit concept regarding the object that is submerged in a fluid, right? That is submerged in a fluid. Now we will discuss this elaborately in this lecture. Suppose this is the object and you have there is a pot here and filled with the water, or it may be any other fluid, any other liquid. So this object or this body is submerged in it. So what will be the pressure is acting on this body, that we will study today. Now, first, that is the Archimedes principle that we have to know. In the Archimedes principle that deals with the forces applied to an object by fluid surrounding it. Actually, what happened whenever in a bathtub filled with the water, just this picture you can see, one person, he has gone to take bath. At that time, some waters that has been displaced and it has been overflowed, right? So the amount of the water, whatever, that is a relationship with the net weight of the object. Here the object is this man. Here the object is this man. So at that time, Archimedes, the great scientist, he has invented this thing, and at that time we know that there will be some Archimedes principle and there will be some relationship between the displaced water with the object weight. Okay, so here what is Archimedes principle? What is Archimedes principle? Now here you can see that there will be one object here. This is the object. This is the object, and this object, and here you have the liquid or fluid also you can say. So this object we are going to submerge in this liquid or fluid, and after submerging this one, you can see that some of the water has been displaced, and this, how much water has been displaced, that is the 3 pounds of water it has been displaced. So in this case, that means whatever the weight of the object, that much has been displaced, that much water or fluid has been displaced here. So according to Archimedes principle, the upward Bonnett force that is exerted on a body immersed in a fluid, whether partially or fully submerged, is equal to the weight of the fluid that the body displaces and acts in the upward direction at the center of mass of the displaced fluid. That means in a fluid, suppose I am just giving one object, it may be fully submerged or partially, but whatever the displaced water, this weight and the weight of this object, both will be equal, right? So weight of the fluid that the body displaces, and if it is submerged at that time, the Bonnett force that will be exerted on this body. So this is the Archimedes principle. Now according to Archimedes principle, Fb, this is the Bonnett force, and rho, this is the density of fluid. This one is the density of the fluid. And G, this G is the acceleration due to gravity. Acceleration due to gravity, and always we are taking this 9.8 meter per second square. So here the buoyant force Fb, that will be rho into G into V, where V is the submerged volume. V is the submerged volume. Okay. Now the Archimedes principle derivation here. Let's derive this thing. So here we know that the density, how much is the density? The density is defined as density, that is denoted by rho, that equals to mass by volume V. So therefore, the mass of the displaced liquid can be written as the mass of the displaced liquid or fluid can be written as follows. That is mass m, that equals to density rho into volume V. Now, the weight of the displaced liquid we are going to calculate. Now, the weight of the displaced liquid can be calculated. Just a minute. Can be calculated as follows. So you know that weight, that is the mass into acceleration due to gravity. So we can write down this is mass into G, and this weight rho into V into G according to Archimedes principle. So from Archimedes principle we know that Archimedes principle, we know that the apparent loss of weight is equal to the weight of the water that has been displaced. So therefore the thrust force is given by rho into V into G, where rho is the density of the liquid, V is the volume of the liquid displaced, G is the acceleration due to gravity. So the thrust force is also called the buoyant force because it is responsible for objects floating, right? So due to this thrust force, the object is floating. So that's why thus this equation, that means rho into V into G, this equation is also called the law of buoyancy. Okay, so this is the derivation of Archimedes' principle. Now one numerical is here. Calculate the resulting force if a steel ball of radius 6 centimeter is immersed in water. So here radius of steel ball is how much? Just a minute. Steel ball, that is the 6 centimeter. So let me change into the unit 0.06 meter. So here the volume of steel ball V, that is the 4 by 3 pi r cube. So that means 4 by 3 pi is the 22 by 7, r that is the 0.06 meter. So this whole cube, and that will come 9.05 into 10 to the power minus 4 meter cube. So density of water rho, we know that 1000 kg per meter cube. So acceleration due to gravity, that is G, that is the 9.8 meter per second square. So from Archimedes principle, formula, that already we know that the force, that is the rho into G into V. So 9.8, that is G, just a minute, thousand, 9.8, 9.05 into 10 to the power minus 4. So this will be 8.87 Newton. Okay, and this is the answer. So this is the resulting force that is acting on the steel ball. That is acting on the steel ball. Next, calculate the density of the body if a floating body is 95% submerged in water. The density of water has been given here. So let's do this thing. They have given density of water, that is 1000 kg per meter cube, and from Archimedes principle, we know that so here VB rho B into G, that equals to rho into G into V, where here I am writing all this parameter. Rho is the density of water, G is the acceleration due to gravity, and V is the volume of water, and VB that equals to volume of body immersed, and rho B that is the density of body immersed. So from this equation we may find out rho B that is nothing but V into rho divided by VB. So here it has been said that 95% is immersed. So since 95% of the body is immersed, so 95% of the body is immersed, that means 0.95 into VB, the ratio of these two volume, that is the 0.95. So rho B that equals to 950 kg per meter cube. Okay. So here we can write down the answer, that is the density of the body is 950 kg per meter cube. Okay. Done this one. Now there are several applications of Archimedes principle we have used in submarine. Here you will know that the submarines we are using for the Navy forces, they are using these submarines. Also for transportation, that means export import, we are using the submarines. Here it is always we are keeping underwater, and there is a component that is the ballast tank, and this allows the water to enter, making the submarine be in position of underwater. So here you can see in this picture ballast tank. So in this picture you can see the ballast tank. Here in this ballast tank there is a facility here where the water will be entered, and so that the submarine will be submerged or fully submerged inside the water. Okay. So this is the application of the Archimedes principle. Another one, that is the hot air balloon. Here the atmosphere is filled with the air, we know that, and that will exert a force on this object, on any object. So in this balloon also some force will be applied. In hot air balloon it will rises and floats due to the buoyant force. So here it descends when the balloon's weight is higher than the buoyant force. So it becomes stationary when these two weights, force and this weight of this balloon, is equal. So this is the hot air balloon. Now in case of hydrometer also we are using the Archimedes principle. Here this hydrometer, what is hydrometer? Where we which we are measuring the relative density of the liquid. We are measuring the relative density of the liquid. Just a minute. We are using relative density. We are measuring relative density of the liquid. And hydrometer that consists of lead shots, which makes them float vertically on the liquid. So this one is the liquid, and here this is the main thing which we are using to measure the relative density of liquid. Now the lower hydrometer sinks, the lesser is the density of the liquid. So here this lead shots, this is actually very important to this hydrometer. Now what is the buoyancy? that is the tendency of the object to float in a fluid. You can see that if you are taking one pot and filled with the water, and now you just take one block of wooden block and you just press it, you can see that it will try to come from this water surface. So that means it has some tendency. The tendency of the object is to float in a fluid. So all liquids and gases, in the presence of gravity, they will exert an upward force that is known as buoyant force on any object immersed in them. So here, now what is the buoyant force? The buoyant force is the upward force that is exerted on an object wholly or partly immersed in a fluid. And this upward force is called the upthrust. So if we have one, and there is some liquid here, and here there is some liquid here, and suppose there is some object here. There is some object here. Okay. And it may be fully submerged or partially, but there will be some force acting on it. And this upward force, that is the upthrust. Now, what are the factors that affect the buoyant force? The density of the fluid. As you know that if you are giving one block inside the water, that is different. If you are taking glycerin and you just want to submerge that same block, the force will be different, right? So the density of the fluid, that affects. Then object whose density is greater, that of the fluid in which it is submerged tends to sink. And if the object is either less dense, then the liquid or is shaped appropriately, the force can keep the object afloat. That's why the shape of the boat, it has been made so that the total area is very high, large amount of area which will occupy. So in terms of the relative density is less than 1. It floats in water or any other liquid. Now, here this is the object and this is the buoyancy, and this object has the mass m, and this object, it will feel some force that is against this gravity. Okay. Here, this fluid column, here you can see that this one, the pressure in a fluid column, that increases with the depth. Thus, the pressure at the bottom of the object submerged in the fluid is greater than that at the top. Now, so the thrust, that is the upward force, whatever applied against the gravity. And this one is our object. So the magnitude of this force, that equal to the amount of the weight of the liquid displaced. Now, why does an object float or sink in a water? Here you can see this is an object, and it is just this object, why it will float or why it will sink. Now, if we see this water at that time, then it has been seen that there are some layers of the water we may consider here. And whatever the pressure of this water level, that pressure is responsible for the event. So the pressure at the bottom of the liquid, that will be greater than the top. So that is the because why we go down and in the liquid, and the number of the layers of the liquid and the number of the layers of the liquid that are overlaying. So this difference of the pressure that depends on the height of this water, and due to this level the object may float or sink. So here it has been clearly mentioned. This is one ball here. Now volume of the bowling ball, that is 4.5 liters. Mass is 10. But here displaced water, if I fall this, if I just dip this ball here, at that time, the whatever the volume of the displaced water, that will be 4.5 liters. The same of the bowling ball. Now the ship floats on the surface of the sea because of volume of water displaced by the ship. The volume of the water displaced by the ship is enough to have a weight equal to the weight of the ship. Okay, so how much water it will displace, the weight of that water, that is equal to the weight of the ship. That's why it will float always. And in this way, it has been constructed. Now the fish, they are very intelligent. So here a certain group of fishes uses the Archimedes principle to go up and down. Now to go up to the surface, the fish will fill its swim bladder, air sacs. There are some air sacs. So swim bladder it will fill, and at that time you can see that it will fill with the gases. So it will go up to the surfaces. Now the gases diffuse from their own body to the bladder and thus makes the body lighter, and it will go upward, and it can go upward condition. So it can float on the water surface also. Now the relative density. Here in this picture we have oil, water, honey. Now here you can see that oil, that is above all the column, then water you have, then honey you have. So why it will happen? Due to the relative density of the oil, water and honey. Okay, so due to the relative density. So density, you know that this density is the amount of mass in a unit volume of matter or substance. But relative density, that means whenever your density you are comparing with the density of water. Okay, so this is the relative density. Here you can see that the relative density, this will be density of substance to the density of water. So density, it is expressed in terms of density of substance in comparison with that of the water. So relative density is the ratio of what? Relative density, that is the ratio of density of the substance to the density of water. Always remember this thing. Now here a list of relative density has been given here. Rubbing alcohol, that is 0.79, lamp oil 0.8, baby oil 0.83, water 1, milk 1.03, liquid soap 1.06, corn syrup 1.33, maple syrup 1.37. So all the values whatever mentioned here, all these values are relative density. That means how much? That rubbing alcohol, it has less denser than the water. But here if you take the milk, at that time it is the density of the milk is higher than the water. So and liquid soap also, it has the higher density than the water. Okay. Let's solve another numerical here. Solution. A globe of steel has a mass of 12 gram, volume of 15.2 centimeter cube. Find its relative density. So first thing, relative density, that is the mass of any volume of substance divided by mass of an equal volume of water. Okay, so mass of 15.2 centimeter cube of water is 1 gram per centimeter cube multiplied with 15.2 centimeter cube, that is 15.2 gram. So relative density that equals to 12 gram divided by 15.2 gram, that is 0.79. Okay, so the relative density is 0.79. Okay, next, the mass of density bottle is 19 gram when dry and empty, and 45 gram when filled with water, and 40 gram when full of liquid X. Suppose I have another liquid X or another liquid other than water. Calculate the density of the liquid X. Here, relative density, that is the M1 minus M0 divided by M2 minus M0, where this M1 is the weight, whatever the mass when full of liquid, and M2 that is filled with the water, right? So I am writing here M1, that is the mass when filled with liquid X, and M2 mass when filled with water. Okay, so here we can find out 40 minus 19 divided by 45 minus 19, that is 0.81. So the density of liquid X is 0.81 gram per centimeter cube. 0.81 gram per centimeter cube. So this is the density of the liquid X. Next, it has been given relative density of silver is 10.8. The density of water is here. The density of water, that is, it will be 10 to the power 3 kg per meter cube. What is the density of silver in SI unit? Now, the relative density of silver, that is 10.8, and relative density we know that the density of silver and density of water, ratio of these two. So density of silver, that equals to relative density of silver relative density of silver multiplied or into, that is density of water, density of water. And if we substitute the values at that time, that is 10.8 into 10 to the power 3 kg per meter cube, kg per meter cube. So this will be the density of the silver. This will be the density of the silver. Okay. So this is the density of silver. Thank you.